Okay, let's continue with the E-Maths revision paper 2. The following diagram shows this rectangle A, B, C, D. Okay, E and F lie on this diagonal. So BD, right, is a diagonal. This is a diagonal. Okay, such that AE, this, and CF, this, they are perpendicular to the diagonal. That means this is a right angle triangle and this is a right angle triangle. Okay, now the question wants you to show that you can try first. The question wants you to show that A, B, E, and C, D, F are congruent. So A, B, E is here. C, D, F is here. Now, if you still remember, we learned about congruent and similar triangles. Okay. Later then we continue that trigo question. Okay, because wait. Okay. Wait. Okay, so we learned that what you call that, congruent triangles, there are 4 tests. Okay, congruent tests, there are 4 of them. The first one is the SSS. That means all the sides are the same. Okay, so let's see whether we can use SSS. We know that this side AB is the same as this side, which is CD. Okay, but other than that, right, we don't know what is the length of this side, we don't know what's the length of this side, we don't know this, we don't know this also. Okay, so we can't use SAS. Now the next one that is a congruence test is SAS. Okay, now can we try SAS? We try, we see, do we know this length? Are these two the same? We are not that sure. Okay, we only know this. We only know this is a right angle, this is a right angle, this. Okay, and is there any other thing that you can see that are the same? Okay, I write down the other two. The other one is RHS, which means that you must have a right angle. The hypotenuse of both must be the same and one more side same. Okay, and the last one is either you can write it as AAS, okay, or ASA. Now, when do you write this and when do you write this? If the side is in between the two angles, then it is ASA. Okay, all other cases where you have two angles and one side, right, you call it AAS. Alright, so let's see. We know this, we know this. Okay, so we have one side already. We have one side. Okay, we have one side. That's not a hypotenuse, right? So we have one side. I don't know whether it's this side or this side. Yeah. Okay, then now we know one angle. Oh, it's a right angle triangle. So let's say we try RHS. Is the hypotenuse the same? Oh yeah, the hypotenuse is the same. But the hypotenuse is actually the side that we know. So this definitely cannot be the answer. Okay, because it must be the hypotenuse and one other side. But we don't know this side, we don't know this side, we don't know the length, you see? So we cannot use this. Okay, and definitely we cannot use this as mentioned just now. So it's just between SAS and AAS. Now, how do you know which to choose? You do the same method as me, okay? Then you eliminate. Okay, now, this one has two sides and one angle. This one has two angles and one side. So if you're able to find one more angle, okay, you already know this angle already, right? One angle, one side. Okay, one angle, one side. If you know one more angle, do you know? Yeah, we actually know that this angle here. I hope you can see my cursor. I've been talking all this while with my cursor. Don't know whether you can see though. Here. I'm talking about here. Can you see it is alternate angles because this is a rectangle, so of course these two sides must be parallel, right? So we have one more angle. That means it's angle, angle, side. Can you see that the side is not in between these two known angles? So we don't say ASA, we say AAS. So the one to use is this fella here. Okay? So you see, now to prove, right, you must always state the equal length or equal angle first, then state the reason. Now if it's given, like in this case, you see, let's see, oh, it's not given, Aiyo, terrible, this answer key. Okay, it's not given, they didn't say exactly that AEB and CFD is equals to 90. They didn't give you here, they didn't. You yourself make the conclusion, because this ABCD is a is a rectangle, right? So the sides must all be right angle triangle. So this is not the reason, okay? It's not given. You should instead say ABCD is a rectangle, okay? So that is the reason, alright? If they specially give you AEB equals CFD somewhere here, yes, then you say given. But in this case, they didn't explicitly say what they didn't give you, no. You yourself, being a very smart student, read the question here, okay, and you know that it's a rectangle, then you conclude that, okay, this one is 90. So this is the reason, okay? Now, the next part is, as I mentioned, this angle here, ABE, this angle here is the same as this angle here using the alternate angles, okay? Yeah, and the last one, right, is because it's a rectangle, this side equals to this side. Yeah, so that's all. And you need to state very clearly the test. Okay, if you don't state the test, it will be 0 for the last part. So you must state the test very clearly. Okay, now the next part, they ask you to show that ABD and EBA are similar. Now, we have done or revised congruence test already, right? Now we're going to revise similarity test. Now similarity test, the most common one is angle. So when you have two sets of corresponding angles that are the same, you can conclude that two triangles are similar. Similar means same shape but different size. Okay, so you have one angle here, same as this angle, then this angle, same as this angle, then you can conclude that they are similar. Don't have to look for the last one. Now the next one is something like this, AAS. SAS similarity, SAS similarity. Now take note, this is congruence test. That means they must be exactly same length. Because this is same shape, same size, same shape, same size. Now, another thing you need to take note of is when two triangles are congruent, right? They actually have the same area because same shape, same size, right? But if it's similar, then it's not. Okay. Now, for similarity test, what is the difference? Similarity test, very simple. If I have this, let's say this angle is 30. Okay, then this is 1, this is 2. Then I have another one. Oops, it's same angle 30. Then this is 2, then this is 4. Can you see that this is like twice of this? Scale factor is like twice, right? When you have a case like that, then you join this end to this end, right? These two triangles will be similar. Okay, now how do you show then that they are similar using SAS similarity? Very simple. You just say, let's say this is A, B, C, this is P, Q, R. Okay, you this S means the corresponding sides are in the same ratio. That means you use PQ. This new one over the old one is 2/1, right? But this new one over the old one also 2 over 1 what? Correct or not? So this PR over AC over also 2 over 1, right? Which is 2 lah. If it's like that, right? Don't you agree they are like having a scale factor of 2 if going from here? Okay, so they are actually similar because you also have this angle must be the same. If this angle this one is 30, then this one is 15, then they are of course not similar already. Okay, so you must state very clearly, BAC equals to QPR, and it's equals to, you must say clearly 30 degrees. How you know? Is given lah. Okay, yeah, then you will say triangle PQR similar to triangle ABC. The reason is this wait no space really. Okay, the reason, right, is SAS. You must say similarity okay. For congruency, right, no need, you just say SAS, right? But for similarity, can you just state that similarity test? Okay, now that is the second test for similarity. Now the third one very seldom come out very seldom come out. It's what we call as a similarity. Okay, what does it mean? It's something like this fella here. But now you also happen to know the last length. So let's say you know that this is 3 and then this is 6. Then you just include there lor. Meaning to say PQ over AB is 2 over 1. Then you find that PR over AC also 2 over R. These are QR over BC also 2 over R. Then you just say SSS similarity. Okay, yeah, so that's how you do it. Now in this particular question, let's try and see how ABD and EBA are similar. Okay, ABD and EBA what I can't remember. ABD and EBA. ABD and EBA. Very difficult to visualize, right? So I don't know whether you still remember the method I taught you. Okay, to remember, and that is to write them one on top of the other. Meaning to say, they want you to show ABD here. So you write as a rough working ABD, EBA, EBA. Isn't it very obvious now? Can you see that banana? The banana angles are the same. ABD, EBA. Your angle ABD must be equal to your angle EBA. How then you say, how do I know? I'm just saying most probably lah. We try and see A B D. Is this angle right here? This angle here. EBA. Allah, they are the same angle. Okay, that's great how smart we are. So it's called common angle. I just say common can already. Common means they are the same. They share the same angle. It's like a common corridor outside your classroom. Common angle outside your classroom. Okay. Now let's go to the next one. What am I talking about? What next one am I talking about? I'm saying you need to see which one fits. Okay. Very likely it's not the S because we are not able to we are not able to determine the length of this, okay, and all the lengths we don't know, you see, so we cannot use SSS. We are trying always to use the angle, okay, this one. So is there another set of angle that we know? Let's see where's my this thing here. Do I know angle A? ABD, EBA, I know already, right? Do I know angle A and E? Angle A and E, then you see, angle A, is it equals to angle E? Okay, see, angle A, right, is BAD. Second, first, 3. Second, first, the third one, BAD, is it the same as BEA? So you see, BEA 90. Okay? Then BAD also 90. Why? Angles in a rectangle. So you say like that, okay? So you use this method, very, very powerful, this one. Yeah, invented by some genius in the, I think 1200 BC. BC. Okay, show that triangles ABD and EBA are similar. We have shown this already. Then you need to say BAD, which is just now that angle up there. You go and look at your paper. This one is a rectangle, right? So this and this are the same. Then they are similar already. AA similarity. Confirm come out. Okay? Confirm. Normally it's AA, but sometimes it's not. Okay, so you try AA first. If AA fails, you go to SAS similarity. SAS similarity fail, then you go to SSS. Okay? But normally no SSS Okay, now next part, getting harder already. Okay, the next part, right, is the next part is this. Okay, let me close this fella. Now the next part, right, is they tell you ABD, AB is to BD is 1:2. Meaning this is 1, this is 2. Let me write down here. Ayo, cannot write. Wait. Okay, can already. Okay, meaning is here AB is to BD is 1:2. AB, okay, 1. This is 1 unit BD is 2. Oh, what does it mean? This whole length is 2, no? Okay, how to write it? I just write like that, okay? Whole thing, whole thing here is 2. Yeah. So how to do? They ask us to find the ratio of the area of the shaded triangles to the whole ABCD. That means they want you to find, right, this shaded area plus this shaded area, okay? This area over this whole ABCD, what is the answer? Like that. Okay? So how do I do this? And why did they give us this 1 and this one 2? Very strange. Okay, never mind. I show you how to do. Okay. You take a look. Normally you see, if you are like given a problem and then you see don't really know how to solve. From the given information here, I don't really know how to solve. Then do what? What do we do? You go to the previous parts. Okay? This will help you and this will help you. Can you see that A, B, E and C, D, F, they are congruent? This one congruent to this one. Agree? Then just now I told you already, congruent means same shape, same size. Okay? So if they are same shape, same size, don't you agree that this is like, if I call this 1 unit square, then this will be 1. If I call this 1 unit square, then this will be 1. Correct or not? Then wait, where did it go? This one auto very lousy this Microsoft Word. I've just written it, then it auto disappear. Okay, never mind. You just remember that there's a 1 here, okay? Don't you agree that because this length, due to symmetry, this length and this length is actually the same as this length and this length, okay? Because they are congruent, okay, it means that this length here equals to this length. Correct. My base same as your base. And if this base is same as this base, don't you agree, ladies and gentlemen? When you turn, I turn the camera like that, right? half times base times height. This perpendicular height must be the same as half times this base. This base same as this base what? Times perpendicular height. Height is not this one not the FA or the DA It must be perpendicular height right here right. So this is the height for this shaded triangle right. So what does this mean? Does it mean anything to you? If it doesn't mean anything to you, then then cannot do already. So it does mean something. It means that this fella has the same area as this fella. Okay? You got it? Okay, so this fella has the same area as this fella, and this fella has the same area as this fella. Okay? And doesn't it mean that this fella also has the same area as this fella? Correct or not? Okay, correct. Okay, now you think about it. If this second part already, wait, I'm showing you the second part. Just now we have proven that this triangle ABE, this triangle is congruent, not congruent, is similar to this triangle. Correct? This triangle similar to this triangle. So what does that mean? What does that mean? It means that this, wait, let me write here. I need the thing to write for you. Otherwise you don't know what I'm talking about. Okay, wait. Can you see that ABD is similar to EBA? Okay, I write like that again. ABD similar to EBA. Easier to see. Okay, you trust me, like that easier to see. But you do by the side. Okay, this is your rough working. It's not the main working. Okay, now you see they are similar. Just now we have proven it already. We've proven it already. So you go back to this part here where I've drawn the area. Okay. Now, do you agree that this AB AB is 1. Just now we say AB is 1, right? AB is 1 unit. 1 unit. This BD just now is 2, right? It's given by the question. BD is 2. BD is 2. Oh, sorry. AB is this AB. The small one is this one. So this is 1 unit. And then BD, right? They told us is 2 units. Oh, what does this mean? It means that if I were to find this area over this area, the small one over the big one, you'll be area of ABE, the small one at the bottom, okay? Here, this one over ABE, that means this one, small one over the big one. Don't you agree? Using A1 over A2 equals to L1 over L2 area, right? So it's square. Oh, this is 1 over 4. Can see not? Which means you see it means that this is 1 out of 4. Okay? 1 out of 4. Okay? And do you see that this ABD, right, is congruent to BCD because they are a triangle being cut into 2 So this area is the same as this area. Do you agree? Okay, if you agree, then you will agree that the answer, right, for this question is just 1/4. Then you ask me, why 1/4? Okay, you see, you imagine, right? You imagine, okay, this part here, just like I told you that this area is actually the same as this area, right? Okay, and this area is the same as this area, what? So you can actually throw this, like your primary school, like that. You throw this into here. So this now, don't you agree that it's actually like 2 over 8? The shaded part, right? This is the shaded part here. The shaded part here is actually 2 shaded parts. Okay, out of these 8 parts that are not shaded. So the answer is 1/4. So that's all. Okay, I hope you understand. Alright, now, this is quite a heavy going question. Alright, I'm now going back to the trigo question that we did in the previous episode because we didn't finish it. Okay, so I left this question hanging. Okay, whether this is correct or not. Of course it's correct Okay, but some of you may not understand. Like, wait, I see whether I can do that. Wow, can do this. Wow, very good. Okay, wait. Wow, very good. Okay, so now, okay, this alpha, this is alpha, this is beta, this is gamma. Okay, you don't have to use alpha, beta, gamma. No need. If you find it, what are you talking about? What are you talking about? Then you use X, Y, Z or P, Q, R. No, don't use P, Q, R because now you got P, Q, R already. You can use any other things like W, X, Y to represent the thing. Okay, so let me explain. Just like I just want you all to have some time to digest. We want bearing of P. So you stand at P, you look north, you turn until you see the S. That is the meaning of bearing of S from P. Bearing of S from P. You are standing here, you look north, you turn until you see S. So you want to find this angle. But how to find this angle? So what we have done, right, is we go and find SPR first. Okay? SPR, where is it? There, SPR. Okay? Okay, I go through step by step. We are trying to find this angle. This angle Y, so that we can take 180 minus this whole thing, okay? This whole thing to get this one. Why must we find this? Because we are using these two parallel lines. These two parallel lines, and then we are using the interior angles of these two parallel lines. Don't you agree that this angle here, which is what we want, right, is 180 minus this SPR here, minus away this, and minus away this alpha. Okay? So that's the whole idea. Alright? So, this is the whole working. This is the whole working, okay? So if you don't understand, you just check with me lah. And of course, this is the final part. Okay? There are a few ways to do it. I've shown you 2 different ways already. I think this is easier lah. The interior angles or parallel lines. Okay? And we have done this part already. There's one more part that I want you to do. Okay, this is confirm come out one because angle of elevation depression is in your Sec 3 syllabus. We brought it down to Sec 2, but we will test you on that. Okay, so you need to know angle of elevation. Angle of elevation very simple. You look horizontally, right? Then you elevate. Elevate means go up. So this is the angle from the horizontal. Okay, again, depression is you must be looking horizontal, then you look down. So this is angle depression. Alright, now whenever they have, you remember in class we did a bird question, also something like that one. All these are points on the ground or on the floor, on the ground Okay, so the water tower is built at R. There is a tower at R, but this tower is not this north line here. It's actually flat thing here, right? It's actually like that. A flat thing here, right? So all your PSRQ, right? They are lying on this flat surface ground okay. So now imagine my computer laptop okay. I turn it this way, isn't it the ground already? So we are actually all on a helicopter looking downwards at all these points, okay? But there is at R, there is a tower at R. So the R, right, when we look down on it, it's actually like a point. You see what I mean? Okay, so this diagram, when we look at it, right, the tower is actually like a point, like my pen like that, okay? But actually when you look at it from the side, it's actually three-dimensional because all these 4 points are on the floor, but this fella is in the air. So it's three-dimensional, right? Okay, so you have to think in that way. How to do the question now? I am going to where's my that thing? Here. Okay, here. We go back to that one. Here. Oh, cannot, Okay, never mind. I try to do here. Okay, so you see, there's a tower here. So maybe I draw like that. You draw another color, you don't draw black because black is already on your question. Ayo, cannot, You will disappear after some time. Okay, so what do I need to do? I let the top, right, be W. Okay, so this is W, and the angle of elevation of the top, here I'm reading here now, angle elevation is from Q. That means when I'm standing here, my eyes are here, I have to look up at this fella, right? This must be 90 degrees because it's a tower, okay? We are now looking by the side view, side view. Okay, those who take D&T, you will know what I mean, side view. Okay, you want to look up to the top of the tower. That's what they mean, And it's 16. Oh, so this must be 16. Alright. So don't you agree that if you want to find the down here, angle of depression of L from the top of the tower, right, is 11. So where is L? The base of the lamppost L is at Q. That means there is a L here. Okay? So do you know what this means? It means that your tangent LQR, okay? Your LQR. By the way, is L here? Alright? So you have to think carefully. The angle of depression of the of L. What is L? What is L? You must really understand what is L. The base of a vertical lamppost LQ is at Q. So what is L? L is like that. So you must draw properly. LQ. This is a lamppost. LQ, they call it a lamppost. You see? Then what are they talking about? Then you say, how are they talking about? So the base of this LQ, LQ is at Q. Then you say, Then you say, what are they talking about? They're just trying to tell you, right, that this lamppost is at Q. Okay, the top of the lamppost is L. The bottom is, of course, Q because this point is Q That's all. Okay, so how do I after that find the height of LQ? So can you see that you have one right angle triangle here already? You can form another one. I use dotted lines. You can form another one here. And this is a right angle also. So looking from here, angle of depression, is 11, right? 11, meaning that this must be 11 also, this must be 11 also, correct or not? Okay, so I hope you understand. You see, your job, as I mentioned in the previous lesson, is a translator. You translate English to mathematical language. And you see, mathematical language are very simple and very simple. Okay, so can you see now that tangent LQR? Where is LQR? LQR. how to tangent LQR? Oh, then they say, it's WR over QR. WR over QR. So is that the correct way of doing the thing? So what we need to do, right, is because we want to find the height of LQ, so we have to do this. We have to find this one first. How to find this one? Tangent of this 16 is opposite, which is WR, right, over adjacent, which is QR, right? Okay, so this is your 86.5. Don't you agree from here you can find your WR? Okay? Can? Actually it's WQR, WQR. Okay, everybody okay? Now after that, right, you see here, once we have found this, this whole thing is 24 0.803. Oh, it disappeared. Okay, never mind. You just label on your own. This one is 24.803. Now we are going to use this dotted triangle here already. Can you see that this dotted triangle here? I erase this. I erase this, okay? So that you focus only here. This triangle here, same, no? This part here is still 86 point. The horizontal distance, right? Although it's in the air, it's still the same, right? Okay, this over this, but this is 24.803. Okay, minus your LQ. Do you remember this is LQ? This length here is LQ. So you minus LQ. That is how we get this fella. Okay, and after you have done this, you so-called cross multiply lah, then you can get the answer already. So that's how you do the question. Okay, we will end this episode here. I hope you are clear. Now trigo is very easy to score. Okay, so you see, from mathematical language, whatever they give you, you see, from mathematical language you translate it into from English you translate to mathematical language. Okay, and for angle of depression, angle of elevation and all that, the key is to draw right angle triangles. Okay, just like 3D diagrams. Alright, we will continue next lesson. Thank you.